I'm going to let Pippa's number be P. And then her list is P. And then we're adding 1 to get a second number, P plus 1. Adding 2 to this second number, that'll give P plus 3. And then adding 3 to this, P plus 6. And finally adding 4 to get a fifth number, P plus 10. I think we can go straight to that. Later on, we're asked about the sum. So I'm going to do it right here. Sum is going to be 5p, 4, 10, I get 20, 5p plus 20. Right, similar for Ben. So he's going with b, then he subtracts 1. So it's going to be b minus 1. In a similar way, he's going to get b minus 3, b minus 6, and b minus 10. So the sum is 5b minus 20. So we're now told that the sum of these numbers are the same. So that means we can set them equal to one another. 5p plus 20 equals 5b minus 20. And we're asked to work out the difference between the two numbers that they first thought of. So the difference between p and b. Well, one approach is to factorize out 5 from each expression. Oops, I don't know why I wrote 40 there. 4. And then we can just divide through by 5. Now, if you're confident, you can actually just divide the whole thing by 5 straight away, because you divide each term by 5. And that's because you can factorize it out. And therefore, we're going to get p plus 8 is equal to b. An alternative way I saw somebody do it is they kind of got the numbers all on one side. They did 5p minus 5b is minus 40, or maybe it was 5b minus 5p is 40, and then they divided through by 5. It's the same thing. At the end of the day, we're going to get p plus 8 equals b, and that gives us the difference. I suppose we could rewrite it as p. Sorry, I'm now rewriting it slightly again, but it's going to be b minus p is equal to 8. That is the difference, the positive difference, but the difference nonetheless. So that's normally what you go with. And therefore, I'm just going to write my final conclusion. Difference must necessarily equal 8. Well done.